This is a video on the chapter 2 exam. So if you got less than a 140, you didn't pass. So I'm going to go over these and make sure that you understand why you missed some of the questions. So I'm going to go over each question quickly. You can pause, rewind if you need to. Okay, it says, number 1 says, which indicates that the forces acting on objects are balanced. Okay, so if the velocity of the object doesn't change, the net force is 0. And if the net force is 0, then the object has balanced forces acting on it. Therefore, the answer for this one is C. It says, what caused the velocity of this ball to change? Remember, velocity is speed and direction. Okay, and so this ball comes up here. You toss a ball, you've seen this before, eventually comes back down. It is so what's changing is the direction of the ball, and the force that is causing it to change is gravity. Okay, that's why it doesn't keep moving in a straight line at a constant speed. Right here it says which is not a vector. Okay, remember a vector has magnitude or size, okay, and direction. Now, all of these, acceleration has size and direction, force has size and direction, and velocity has size and direction. Okay, the only one that doesn't is mass, because we know that mass is the amount of matter that's in an object. Right here, a lot of people miss this question. It says if the vertical forces acting on the box are balanced, so that means here and here, if they're balanced, okay, what would be the net force on the box? So if they're balanced going up and down, that means we only need to look here. Here we have one going 12 newtons to the right, 1.2 newtons to the left. They're going in opposite directions, so this box is going to move to the right, and the net force is going to be the difference between those. So 12 minus 1.2 newtons is going to be 10.8. Okay, we can cross out A and C because we know it's not going to move to the left, and if we know that we subtract, we get that. Now it says, what's the acceleration of the box? You have to think here. We know that acceleration is equal to force over mass, or you should know. Okay, and so we know that the force acting on the box from the previous question is 10.8. And we know the mass of the box, because they give it to us right there, is 2.5. Okay, and we know the box is going to go to the right, so we know it's not this one or this one. Okay, and 10.8 divided by 2.5. Okay, you do the math, and you're going to get D, 4.3. And it's going to be meters per second squared, because we're looking for acceleration. 6, it says which statement is true? Okay, the weight of an object depends on the gravitational forces attracted to it. Okay, so mass doesn't change depending on your location, so it can't be A or B. Okay, and the weight of an object is not a frictional force. Okay, so it has to be D. Now, this has to do with the law of universal gravitation. You have two objects, A and object B. Okay, and the attraction depends on the distance between them and the size of the objects. Okay, so it says which would cause the gravitational force to increase. So if the objects move closer together, then they're going to have a stronger attraction, because the closer two objects are, the stronger the gravitational force. So the answer has to be C. It says a ball is moving in a circular path. Describe the net force on the ball. We talked about this many times. Okay, if it goes this way, that way, the centripetal force is toward the center of the circle in each case, and perpendicular to the motion, okay, of the ball. Okay, so that is going to be where the net force is, which keeps it going in a circle. So the answer had to be D. The key here was that you was perpendicular to the ball's path. Number 9 is pretty simple. These dudes are pushing, or this guy and this girl is pushing in the same direction. When forces combine in the same direction, you add them. 100 plus 190 or plus 95 is 195, and they're going to go to the right. Okay, so you shouldn't have missed that. This is a little bit more tricky. This might have been the most difficult question on the exam. Okay, now look, if you read the graph though, it says time is passing here and the speed is here. So we see as time is passing, this object speeds up and then it slows down. Okay, so it says over what time interval is the force on a book in the same direction as its velocity? So remember, when an object is moving, if a force comes along in the same, if it's already moving and a force comes along in the same direction, it causes it to speed up. So you need to ask yourself, where in this graph is the object speeding up? And so you can see here from 0 to 0.5 seconds, the speed is increasing. Okay, so that's why that is the answer is A. 11. Okay, it says the speed of a soccer ball is decreasing. That means it's slowing down. So when objects slow down, remember that that's because the net force is going in the opposite direction that the object is moving. So therefore, the answer for this one needs to be D. Now it says when you stretch a string by pulling one end to the right, describe the net force exerted on the spring. Okay, when something is being stretched, as we have learned before, that's a tension force. And if it's being pulled to the right, it's going to be a tension force in the direction of that spring. Right here, this is a definition of force is a push or a pull on an object. Okay, gravity and magnetic force are examples of non-contact forces because they exert forces, but they are not touching. Right here, number 15, this is vectors have direction only. That's false. You should know that vectors have magnitude, okay, or size, however you want to say it, size and direction. Okay, that's why that was false. This right here would be Newton's first law, okay, because the object at rest wants to stay at rest or its velocity won't change. We've been over that many times. We also, weight is a vector. It has size and direction. Its size is however much you weigh. The direction on Earth is going to be towards the center of the Earth. 18, 19, and 20. Okay, these were all these answers were up here. Okay, hopefully you do them. If it says what force is responsible for the weight difference in the weight between gold in San Francisco and gold, and in this case it would be the force of gravity. It says that up here in the text is responsible. It says what initial solution did they come up with to try to fix it. Okay, it says over here they tried to ship the scales with them, okay, because they thought the scales might have been the problem. Okay, but that didn't solve the problem because the difference was that the San Francisco and Denver were at different altitudes, and that was why the scales were showing different weights. Okay, so you can go and read that, pause it, rewind, write that down. And it says although the wave of the gold changed from place to place, what stayed the same. It tells you up here, if you keep reading, that the mass is always the same because mass does not change depending on your location, but weight does. So if you didn't get any of that because I went too fast, go back, rewind, do what you need to do, but correct your answers so that you know why you missed them.